Today we are covering Topic 9 from the AQA CGP Chemistry Guide. In Topic 9 we are covering the Earth's atmosphere, the history of the atmosphere, climate change and air pollution. Topic 9. Chemistry of the atmosphere. The evolution of the atmosphere can be split into three phases. In Phase 1, the surface of the Earth was riddled in volcanoes that released many gases. This formed an early atmosphere made up of mainly carbon dioxide, nitrogen, water vapour, and trace amounts of methane and ammonia. There was no oxygen originally, making it similar to Mars and Venus's atmospheres today. In Phase 2, the oceans formed as water vapour condensed. This allowed a lot of the CO2 to be dissolved into the oceans. This then went through a series of chemical reactions to make carbon precipitates on the seabed. Green plants and algae evolved, absorbing more of the carbon dioxide for photosynthesis. Later also the marine animals evolved, and their shells and exoskeletons contained carbonates from the oceans. When they died, they got buried in layers of sediment that compressed them to form fossil fuels, thus trapping the carbon underground. Crude oil and natural gases are formed from deposits of plankton that got trapped under the seabed. Coal is made from thick plant deposits. Limestone is made from the shells and exoskeletons. Phase 3 is when the plants and algae made a large change in the atmosphere by producing oxygen via photosynthesis. Algae first evolved 2.7 billion years ago, and then up to 1.7 billion years ago, green plants started evolving. As oxygen levels increased, more complex organisms like animals started to evolve. About 200 million years ago, the atmosphere reached a similar composition today, of 78% nitrogen, 20% oxygen, and 2% carbon dioxide, noble gases, and water vapour. Greenhouse gases keep the Earth warm enough to support life. These are mainly carbon dioxide, methane, and water vapour. Particles such as these absorb the long-length radiation and re-reflect it back to Earth, trapping more heat inside. Human activity is causing a large increase in carbon dioxide concentration in the atmosphere by deforestation, burning fossil fuels, agriculture, and creating waste and other chemical processes. Although the Earth's temperature does vary naturally, human impact is causing the temperature to go above the normal peaks, especially as we are supposed to be entering another glacial period soon. But no overall drop in the temperatures in the Northern Hemisphere can be seen. This effect is called global warming, which is the rise in the average temperature over a long duration of time. Global warming causes climate change, which can mean other feedback loops come into play. This can make weather more extreme and unpredictable in very complicated ways, which scientists cannot yet fully understand. Unfortunately, speculation in the media has led to a lot of misinformation about climate change. But it is important to know that if we do not fix it in the next 50 years, many human and animal lives will be put at risk. Sea level rise is resulting in many communities leaving their homes near the ocean, and it is predicted if global temperatures rise by an average of 1.5 degrees C, sea level rise will displace 2 billion people by 2100. Changes in rainfall patterns will make the climate too extreme to successfully grow crops in places such as Central Africa, and this will displace many more people and contribute to growing food insecurity. The rise in sea temperature by just 1 degree C will make many more tropical storms, destroying people and their properties across America, Oceania, and Asia. To reduce our carbon footprint, to slow down climate change, we must know what we are spending carbon on. Carbon footprints measure the amount of carbon and other greenhouse gases released over the full lifetime of something. It could be you over the course of a year, a service, an event, or a product. Basically everything has a carbon footprint of some sort, but measuring this exactly can be very hard. It would need to take into account all of the carbon emitted from manufacturing, using, and disposing. However, rough calculations can tell people what activities are the most carbon intensive. Driving polluting cars for a year and taking a single aeroplane ride are both very carbon-intense activities. Eating animal-based products, having many children, and even how your house is powered also hugely affect the amount of carbon that someone consumes over their lifetime. There are many ways of reducing carbon footprints though. The UK grid is increasing in the amount of renewable electricity it consumes and decreasing fossil fuels. Cars are switching to electric or hydrogen fuel-based instead of diesel or petrol consumption. There are also many active processes to remove CO2 from the atmosphere, either by machines or reforestation. And legalization on chemical process emissions, or those from cars, can encourage people to choose more efficient ones if they can afford to do so. Although climate change is a pressing problem, countries are afraid to make the changes necessary, in fear of damaging their economies. And at present it is difficult to tell how coronavirus will impact this as well. Finally, air pollution is another issue to solve alongside climate change. When fossil fuels are burned completely in enough oxygen, they produce CO2 and water vapour. However, in incomplete combustion, where water is limited, can create carbon monoxide, soot, and release unburned hydrocarbons. These types of particles can cause problems, such as lung damage, leading to respiratory problems and global dimming, where less light reaches Earth because of reflection. Carbon monoxide in itself is very dangerous because it binds to the enzymes in your red blood cells, limiting the amount of oxygen you can take in. This can cause fainting, coma, and frequently death. It is also very difficult to detect, making it even more dangerous. Sulfur dioxide is formed from impurities in the fossil fuels. When this mixes with clouds, it causes acid rain, which can be very damaging to local environments. Buildings, statues, and corrodes metal. Nitrogen oxide can also be formed from nitrogen reacting with oxygen in heated environments, such as inside petrol engines. This also causes acid rain, and both are also bad for human lungs, causing respiratory problems. Thank you so much for watching this video. Leave a like, share to your friends, and comment any questions you have down below. See you in the next one.